All right, we're recording now. So this is where I'm going to try to show the students how to solve the problems on this worksheet that I gave you for force, work, and power with the water wheel like you were doing in class. So I'm going to use this sheet here. It'll look a little different than yours, but it's a little um, spread out, a little more for me to be able to show you what's going on. All right, these questions for number one are all straightforward. You know, the force is equal to the mass times the acceleration of gravity. So for all these problems for acceleration, it will be 9.8 meters per second squared because we are lifting them against Earth's, the pull of Earth's gravity. Then your work will simply be the force times distance, and the power will be the work divided by the time. These are just straightforward like we showed you in as examples in the classroom. All right, now on to the other ones. They're a little bit more complicated, I guess. So I'll talk you through them, and I will later post all the worked out solutions on the web page. All right, so you look at the information we're given. We're given mass, we're given the distance it was lifted, and the power output. And we're trying to find out how long it took. So we'll need to find eventually time from power equals work over time, but we don't have enough information there to start with. So the first step in solving this is to find the force, which will be equal to the mass times the acceleration. So you've got mass there, and the acceleration of gravity, as always, is going to be 9.8 meters per second squared. The second step will be to find the work. You find work from force times distance. You know, found the force up here. You know the distance it was lifted, so you'll now know the work. Then the third step is to find, or the last step is find time from power equals work over time. You'll need to rearrange that equation for time, and you should get an answer of 15 seconds. All right, moving on to number 3. In number 3, you're given a little different information. You got mass again, you got time, and again the power output, and you are asked to find the distance the mass was lifted. So you'll need to find distance from work equals force times distance, but we don't know the force yet. We'll have to work back, or let's see, we don't know the force and the work, so we'll have to figure those out. Step 1 is to find force, because that will be the mass times the acceleration. Acceleration of gravity again, 9.8 meters per second squared. And you're given the mass, so now you'll know the force. 2, the second one, we'll have to do this in a different order. You need to find work from power equals work over time. You were given the power up here, 0.196 watts. You were given the time, so you can work backwards to find the W in the equation. Then step 3, the equation work equals force times distance, because we're looking for distance. You know the work. You figured it out in that step. You know the force up here from step 1, so you can rearrange the equation to find the distance. And the distance you should find ends up being 1.2 meters. So make sure, if you can't get 1.2 meters, go look at the worked out solutions when they're posted and see how you need to go about it. Or that's the same as 120 centimeters. All right, moving on to problem number 4. I gotta switch papers over here. Problem number 4. Your first step. Oh, now we're asked for mass. You know the distance, you know the time, you know the power output. So to find mass, the only place mass shows up is our force equals mass times acceleration. And we're looking for this, but we can't start there. We need some other information. Step 1, the way I did it here, is power equals work over time, and you solve for work. We've got time here, we've got the power, you find the work. In step 2, from the work, you can find force. So work equals force times distance. And we know work from 1 up there. We know the distance from the information we were given, so you can solve for force. Then step 3, since you know force equals mass times acceleration. You solve force in step 2. Acceleration is always 9.8 meters per second squared in the way we were doing the water wheels. And you can now solve for mass. You can find the mass at this point. And you should get, for number 4, you should have a mass of 0.2 kilograms. Or, in other words, that's 200 grams. That is a 200 grams. Step number 5, or question number 5. Water wheel lifted an unknown mass a distance of 120 centimeters in 25 seconds, producing 2.0 watts of power. So in number 5, 5A, how much work was done? Power equals work divided by time. And you know the power. You know the time, 25 seconds, and you can solve for work. And when you solve for work in this one, 5A, you should get a work of 50 joules. Again, I'll post out the written out solutions later. Now the mass, what was the mass here? Alright, so we're asking for the mass from the same information up here. The first step you need to do is from work equals force times distance. You can solve for force. You know the work from up here. You know the distance right here. And now you will know the force that was in operation this time. Then the second step in that one, since force equals mass times acceleration, you can now find the mass. Right? You can solve for m. You got force from step 1 here. You got work from the power, and so you know force. You know what the acceleration is, and you can find the mass. And you should get in 5B a mass of 4.25 kilograms, or 4,250 grams. So that would have been a little better water wheel than we were able to construct with our materials. Now for number 6, I'm going to stop the recording and I'm going to make a separate recording for number 6 because this video is getting a little long.